So hi everyone, how you guys doing? All right. So first of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IIT. And on this particular channel of Unacademy, every concept of physics, chemistry, and maths are being taught to you completely in English. Now, this is a series that I host for class 12 students, and the topic that we are discussing right now is ray optics. This is lecture 10 of ray optics, and today we'll be talking about prisms. All right. So before we get started with today's discussion, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit, and I studied mechanical engineering from IIT Delhi. And for almost past 8 years now, I've been teaching physics for the IIT JEE Mains and advanced examinations. Now, most of this teaching so far, before previous year, had been in offline setups. Now, last year was the first time that I started teaching online, and that's been my journey so far. Okay, so as a student, I myself was All India Rank 447 and All India Rank 192 in the two stages of the IIT exams that I took. Now, I had also qualified the NTSC Stage 2 examination, and I was in the top 1% in the NACP exam as well. Now, I've already coached many students to top ranks in the IIT exams in my offline teaching career, and now I hope to keep guiding you guys through, to your dream colleges and dream ranks through this new online setup. Yeah. All right. So students who are worried about how they can continue with their studies uninterrupted, even in this period where people are hardly getting access to their educators and good education. So there's a great way for you guys. You guys can get yourselves the Unacademy subscription. Now this subscription gets you huge benefits like live classes where you get to interact with your educators on a regular basis. Now these classrooms also have live polls and leaderboards. Now, there is also regular testing. So there is a test series that you're part of and regular analysis sessions which keep you on your toes and keep you aware of your standing in the competition. And finally, of course, you have live doubt clearing sessions. So after every three teaching session in all academic class courses, every fourth session is supposed to be a live doubt clearing session. So one session after every three teaching sessions dedicated entirely to your doubts, where students may ask any kind of questions about the theory part that they did not follow or have any confusion about, or problem solving, any difficulties that they are facing in that. All right. So along with all these benefits, of course, you are also getting the chance to study from the topmost educators from all across the country, from the comfort and safety of your home. So I think that's a wonderful opportunity for all the students out there, and everybody should try and make a full use of this. Next, of course, how do you start availing these benefits? So the first step involves for you to install the Unacademy app. Okay, now the moment you do that, you will realize you can unlock for yourself a lot of free features. So there are free courses running on Unacademy app. So you can simply download the app and enroll in these courses. Okay, so that those are completely free. Then you have something called special classes. So every educator conducts some special classes every week. For instance, I also conduct about three special classes, 2 to 3 special classes every week, and you can take part in for these simply by installing the Unacademy app. Then, of course, you have quizzes. So quizzes like we keep conducting every Tuesday. So all these features are absolutely free, no subscription needed for these. Okay, all you need to do is install the Unacademy app and you can unlock all these free features with the invite code RD Live. So you'll be asked an invite code. So you can use this code, my code RD Live, and simply unlock all these wonderful free features. Okay, next you will realize that once so these features will definitely give you an idea of how your plus courses are going to go like and how your preparation is going to be with the Unacademy Plus. So once you are convinced you like what you see, then you can decide to get yourselves the Plus subscription. And when you decide on that, then these are the steps that you need to follow. You can go to the Plus section of the app, select your goal as IIT JEE, and click on that Get Subscription button. Now, the moment you do that, you will be redirected to the payment page where you will find a box which will say, do you have a code? So that is where you can enter this code RD Live. So this code will give you a 10% off on all your subscription fees, be it the plus subscription that you're opting or the iconic subscription that you might be opting. So these are the two subscriptions that you can go for. These are the offerings which are being made by Unacademy. So, and the fees of all these subscriptions are as mentioned here. And finally, when you click on proceed to pay, you will realize you also get a choice to break these payments into no cost EMIs, a lot of no cost EMIs. So you can pick a suitable no cost EMI plan, which will make this burden very less. So hi Rajesh, how are you? Next, those of you who don't know what the iconic subscription is all about, let's tell you quickly about that. So the iconic subscription will take your IIT JEE preparation to the next level by allotting you personal coaches. So from our team of experts, you will be allotted personal coaches who will personally mentor you and guide you throughout your IIT JEE journey. Now you will also be attending a lot of IIT JEE workshops, receiving expert guidelines from time to time, getting a study planner, which I think a lot of students can use because a lot of students struggle with their planning of their studies. And finally, you have a lot of test and analysis sessions. So you get these benefits and a personal coach apart from your plus benefits. So this will definitely help you power through your ITJ journey. Next, the students who have just entered class 11th and are confused about how to begin their preparation and how to go about their preparation, you guys can select combo subscriptions offered by Unacademy. So Unacademy is now offering you 10 kinds of combo subscriptions wherein you can not only take care of your class 11th CBSE studies, class 12 CBSE studies, and hence you're getting prepared for boards. Then you have preparation for for your IIT JEE Mains and IIT JEE Advanced. So you can go for either of these subscriptions and they'll help you through all your study worries. So the four subscriptions offered by Unacademy are as follows. The first combo offers you the iconic subscription for IIT JEE and the plus subscription for 11th and 12th. And this combo starts at around 4,600 a month. The second combo that you can choose from is the iconic subscription for all three. And this combo starts at around 5,500 a month. Finally, you have another combo which offers you the plus subscription for all three. And this combo starts at 3,000 a month. And finally, you have a combo which offers you the plus subscription for IIT JEE and the iconic subscription for 11th and 12th. And this combo starts at 3,900 a month. Now, this is a list of the upcoming tests in January that you should not be missing out on. So the Unacademy Combat next event is going to happen live on 31st of January. Make sure you take part in this and you can enroll now using the code RD Live. Then you have Advanced 2021 test series that is happening every Saturday. All these exams are completely free for you guys. So make sure you're not missing out on these. And then you have unique DPP discussions happening every Monday through Thursday. Okay, so make sure you are utilizing all of these opportunities provided to you by Unacademy. Next, the students who are following us on the JEE English channel of YouTube can definitely connect with us on the Telegram app using this link. So what happens is that a lot of time I receive feedback from students that they have subscribed to the channel, they have pressed that bell icon, they're still not receiving timely notifications from YouTube. So this, if when you join this Telegram group, that will make sure that you are getting all the notifications of every lecture and session happening here on this channel, and you're not missing out on any of the amazing content being provided here. All right, so make sure you join this channel. All right, so finally, let's get started with today's discussion. As I said, so hello Aftab, hi AP, how are you guys doing? So today we'll be talking about our discussion of prisms. So before we start discussing prisms, let's talk about this one thing that we had left for lenses in the last class. So we wanted to talk about the combination of lenses which are separated by a distance. Okay, so here imagine you have two lenses. Okay, and the first one has a focal length of, let's say, f1. The second one has a focal length of, let's say, f2, and these two have been separated by a distance d. Now we want to replace both these lenses by a single lens. So this is the single lens that we are trying to replace both the lenses by. So there are two things that I am interested in finding out. One is the position of this lens, and second is, of course, the focal length of this lens. So the idea is that if I replace these two lenses by a single lens, then one, it should focus a parallel beam coming from infinity to the same point as the two lenses would have done, and second is the deviation produced should be the same. The deviation produced by the single lens should be equal to the deviation produced by the two combined lenses. Okay, so here is a ray diagram that you need to pay attention to. So in this ray diagram, you will realize you have been shown a light ray coming here. After the refraction from the first surface, it becomes like this, and then after the refraction from the second surface, it becomes like this. So if I wanted to replace these two lenses by a single lens, then what would have I done? I would have imagined that if this light ray was coming from infinity and incident on this single lens, then after refraction, it should have gotten focused on this point. So this should have been the focus of this lens, and also the deviation produced by the light. So you realize the first lens produces a deviation. Okay, so let's get rid of these colors. The first lens is producing a deviation of delta 1, and the second lens is producing a deviation of delta 2. So the total deviation produced in the light rays path is delta 1 plus delta 2. You want now that single lens should have produced exactly the same delta also. Okay, so that you know that the single lens can be taken as the equivalent of the two lenses. Okay, so does everybody follow this? Okay, hello S Pandey, how are you? All right, so let's try and figure out the F equivalent of the equivalent lens and also the position. Let's say this is some distance x. So what I want to find out is, okay, so above we have already mentioned x1 and x2. So if I can find out either x1 or x2 and the F equivalent, then I'm done. Okay, so that is going to be our aim. Okay, now let's see. Hello ARJ, how are you? Now let's see how we would have gone about it. So I know, after the refraction from the first surface, the image is formed, let's say here, and I know this distance should have been equal to f1, correct? So this is a parallel, this is a beam which is parallel to the principal axis. So after refraction from the first lens, the light should have gotten focused on the focal point of the first lens, right? So I can imagine that this distance would have been f1, right, where the image is formed. Now you realize this image would have acted as an object for the second lens. Okay, so for the second lens, what I can say is that this would have been the object distance, u2, and u2, can I say, would be f1 minus d. Okay, so yeah, I just lagged a bit. Yeah, I know. So yeah, that just the net just fluctuates a bit sometimes. All right, so let's get started with our analysis. Okay, so I'm saying let the incident ray parallel to the principal axis get focused to f1 after diffraction through L1. L1 is the lens 1. Okay. So now what I can say is, therefore, for L2, the U, let's say U2, would have been equal to F1 minus D, where D is the separation between the two lenses. Agreed? Okay, I hope so far there is no confusion and everybody is following what we are trying to say. Okay, now my aim is to find the final position of the image. So let's call this one V2. Okay, so I eventually want to find V2. Okay, therefore what I can say is, applying the lens formula, applying the lens formula for L2. Let's see what that will give me. For L2, if I apply the lens formula, what I'll get is, I'll get that 1 over V2 minus 1 over F1 minus D to be equal to 1 over F2, correct? Okay. So now once I know this, so what I get is, therefore 1 over V2 equals 1 over F1 minus D plus 1 over f2. Now, please note that the signs have already been taken in. Okay, the first image was formed towards the right of L2. Okay, so that is why I haven't added any negative sign here. Okay, here I have just simply taken this as positive. F1 is already positive, and the separation is assumed to be less than less than F1. Okay, here the signs have already been taken care of. Okay, so this is what I'm getting. So let's see what that gives me. So here I have found the position V2. Okay. Now all I need to do is, so therefore from here I can say V2 would have been F2 times F1 minus D over F1 plus F2 minus D. Okay. This is the position V2. Now I want my equivalent lens to have this exact focal length, right? So can I say if the equivalent lens is kept here, which is at a distance of x2 from L from lens 2, then this would be the F, correct? F equivalent. Now, what is the F equivalent? F equivalent, can I say, would be simply V2 plus x2. So therefore, F equivalent will become V2 plus F2, correct? So that is the first equation that I've got. Next was that I wanted to say that the single lens should have produced the same amount of deviation as produced by the two lenses. Okay, so let's call let's give these heights some names. Okay, so let's call this height 1. Let's call this height h2. Okay, and let's call this height some h. This is not needed. This entire height would be h. Okay, so I know. Also, I want delta to be equal to delta 1 plus delta 2. Correct? Okay. So now what I can do is that I can write delta as h1 over f equivalent, which should be equal to delta 1, which would be f1 over f1, h1 over f1 plus delta 2, which would have been h2 over f2. Correct? I hope you remember this from our discussion in the previous class. Okay. The deviation produced by a lens is h over f. Okay, so this is my second equation. All right, so I have got these equations. Now, if I can rewrite h1 in terms of h2, h2 in terms of h1, then I should be sorted, right? Let's add another page. Now, if I notice carefully, what do I see? Let's say, so this was the light ray. So now what we will do is we will say that if I want to find this distance, hello. So how can I write this distance? This is delta 1 and this is d. Now assuming again all are paraxial rays. Okay, assuming all rays are paraxial. Again, here will be a small approximation. The approximation would be that all these deviations would be small. Okay, so what I can write is h2 minus h1 minus h2, sorry, h1 minus h2 should be equal to delta 1 times d. Correct? So if all the angles are almost equal, then what I can are almost small. So the assumption here is delta 1 tends to 0, delta 2 tends to 0, and hence delta also tends to 0. So all the angles are tending to 0. Okay. So that is how what I'm doing is that this distance, if I look at this triangle, okay, so let's look at this triangle. Okay, so let's give this triangle a name. Let's call this A, let's call this B, and let's call this C. If you look at the triangle ABC, so tan of delta 1 is BC over AB. And tan of delta 1 can be roughly written as delta 1 only, and that is how I'm saying h1 minus h2 would be equal to this. Okay, so from here, what I realize is, therefore, what I can replace h2 as, h2 can be written as h1 minus delta 1 d. Okay. Now I will replace this value in this expression. I will replace this value in this expression of ours. Therefore, what that gives me is equation 3. Substituting this in equation 2, what we get is h1 over f equivalent is equal to h1 over f1, and it was equal to plus h2 over f2. So 1 over f2 times h1 minus, again delta 1 can be written as h1 over f1 times d. Correct? I hope everybody followed this. So from here, what I realize is I can cancel out all the h1s, and what I'm getting is, therefore, 1 over f equivalent is equal to 1 over f1 plus 1 over f2 and minus d over f1 plus f1 f2. So this is my expression of equivalent focal length. Okay. This is the equivalent focal length of two lenses separated by a distance d. You realize if d was 0, then I go back to my formula that P equivalent power is nothing but P1 plus P2. Okay. So half the part is done. F equivalent I calculated. Now in the next half, I needed to find the position x2. Okay. Now that can be calculated from this equation. I also know that F equivalent should be equal to V2 plus F2, and V2 I already knew from here. Okay. So let's use that and try and calculate the value of x2. Okay. No, not V2 plus x2. The F equivalent here would be equal to, this was V2, right? This was V2 and this was x2. This should be V2 plus x2. So all I will do is now substitute the value of the F equivalent and the value of V2 as calculated from here into these expressions. Okay. So what I get is, let's see. Or I can use a shortcut actually. I can rather use a shortcut instead of using this. So let's take another shortcut for calculating this position. I can also say that this length BC, also say that this length is going to be delta times x2. Okay. Hello Dinesh, how are you? Okay. So we'll use that. That'll just make our calculations slightly shorter. Okay, I can also say that BC would be equal to this delta. This angle is delta. So delta times x2, correct? So I had already calculated BC, right? Earlier I had calculated BC as delta 1D. So I can say also delta 1D would be equal to delta times x2. So from here I can easily figure out the value of x2. And I know delta 1 was h1 over f1 and a delta was h1 over f equivalent. So that will simply give me that x2 should be equal to f equivalent g over f1. So that is the position of the equivalent lens. Its distance from L2 should be this much. Okay. So I hope everybody followed this. I don't know if that is visible, this lower part. Okay, maybe I'll rewrite this again. Sum it up. So I can say, so if I had L1 and L2, L1 was here, lens 1, having focal length f1. Then I had L2, this lens here, having focal length f2, separated by a distance of d. Then my equivalent lens having a position L equivalent, having a focal length of f equivalent, and being at a distance of x2 from here and x1 from here, what I realize is 1 over f equivalent is equal to 1 over f1 plus 1 over f2 minus d over f1 f2. Right? So that is how I figure out my equivalent of focal length. And also the next thing I wanted to figure out was the position. So x2 I have figured out should be equal to f equivalent b over f1. And when you analyze, you will also realize that x1 would become f equivalent b over f2. Okay, so you can figure out the value of either. Okay, so this is the final result that I need to remember. So very important equations. This is the equivalent focal length of two lenses separated by a distance d, and this will give you the position of the equivalent lens. All right. Okay, I hope it is clear to all. Again, maybe you can go through the derivation once more and figure out. So this is where we started our discussion with. So I said let us incident a parallel beam, a beam which is parallel to the principal axis on the lens L1. Okay, and after the refraction from lens L1, this beam should have tried to focus on the f1, the first focal point of lens L1. Okay, Now imagine that in the middle it meets L2, and from refraction through L2 it reaches the position I2. Okay, so this is the final thing. So the F equivalent is if I replace these two lenses by this single lens, okay, by this single lens, then what I realize is that this entire distance would be called the F equivalent. Why? I'll imagine that this ray falls or is incident on the equivalent lens, and converges to this point I2. Okay. Now I also wanted the deviation produced by the single lens to be equal to the net deviation produced by the two lenses. Okay, so I wrote that also. I wanted that this delta produced by this single lens, which is this, to be equal to the sum of the net deviation produced by the two lenses, delta 1 and delta 2. Then I gave these heights some name. I called this one H1, and of course this also becomes H1, and this I called H2. So the deviation produced by the first lens would be H1 over F1. We discussed this in the last class, that deviation produced by a lens is equal to H over F. And similarly, the deviation produced by the second lens would have been H2 over F2. And the deviation produced by the single lens would have been H1 over F equivalent. So after this, I rewrote this like this. Okay. So here, if I could find H2 in terms of H1, that would have solved my problems. So then what we did was we assumed that all rays were paraxial. Then what we realize is that if I take a look at this triangle, okay, so this one was my H1. This one was my H2. So what I realize is if I focus on this triangle, choose a separate color for I focused on this triangle, this particular triangle. Then this angle is delta 1. Right? This angle was delta 1. This side AB was D. Okay, and this side was nothing but H1 minus H2. So I can say that H1 minus H2 over D is nothing but tan of delta 1. Then I use the small angle approximation. Okay, so what I wrote was that H1 minus H2 should be equal to tan of delta 1 times D, and I applied a small angle approximation, and that is how I wrote tan of delta 1 roughly equal to delta 1. Okay, assuming that the angles of deviations are small. We're talking about all paraxial rays. Okay. So then I got H2 as H1 minus delta 1 times D. Okay. Now then we substituted this in the previous equation, which said H1 over F equivalent should be equal to H1 over F1 plus H2 over F2. Okay. Then I replaced delta 1 as also as H1 over F1. The moment I did that, I got this expression. Okay, so this was the derivation. I hope everybody followed. Again, if you have any doubt, you can let me know. Finally, to calculate, next thing that I wanted to find was the position of the equivalent lens. So for that, I also looked at this figure again, and now I focused on another triangle. Okay, now the triangle that I focused on was this one. So in this triangle, if this distance was x2, okay, and this was definitely h1 minus h2, what I wrote was tan of delta. This angle was delta, right? So what I wrote was tan of delta equals h1 minus h2 over x2. So from here I got h1 minus h2 equals delta times x2, again using the small angle approximation. So that is what I wrote, that x1d, which was essentially a delta 1d, which was essentially h1 minus h2 is equal to delta times x2. Now I know that a delta 1 would have been h1 over f1, and a delta would have been H1 over F equivalent. So from here I got X2 related to F equivalent and F1 and D. Okay. Hello Anjali, how are you? So after all the analysis, these are the final expressions that I have gotten. Now I can replace these two lenses with this equivalent lens. Okay. Please remember these final formula. Even if you don't remember the derivation, that's fine. The derivation is just for you to understand how we got to this. The final form of the formula is very, very important. You must remember this. Okay. The location of the equivalent lens and the focal length of the equivalent lens. This is what is important. The final results. Okay. Again, if you have any confusion regarding this derivation, you can let me know. Otherwise, I'll move ahead. If everybody followed this, then let me know. I'll just move ahead with the discussion then. So, any confusions? Just remember these results. These are pretty important. Okay. So since nobody seems to be reporting any confusion, so let's just move ahead. All right. So why don't we practice a problem then from whatever we have learned? So here you've been told a convex lens L1 of focal length 20 centimeter. Acha, please note that put every focal length with proper signs in these formulae. Again, use proper signs. I cannot say that enough. Okay. Now you will also realize if the final equivalent also if F equivalent it comes out to be positive, combination behaves as a diverging lens or converging lens. And and if equivalent finally comes out to be negative, the combination behaves as a diverging lens. Okay, so again, you must remember all these sign conventions are very, very important. They decide how the combination is going to behave. Okay, if you don't use proper signs, you will get the wrong answers. And then I've seen this happen that students do not follow proper signs, they get wrong answers, and then they say, "Sir, we did everything that you taught, and we still don't get the answers. Maybe you taught us something wrong." Okay, so always remember to apply your formula properly. All right, now let's take a look at this question. This question says a convex lens L1 of focal length 20 and a concave lens L2 of focal length 5 are kept along the same axis separated by a distance d between them. For what value of d, a parallel beam incident on the first lens leaves the second lens as a parallel beam. So try this and let's see if how many of you guys can give me the answer for this. So this should be very, very simple now. Okay. Hmm. So hurry up, try this, and let's see how much you followed from our discussion. So I think we have just a couple of more uh, things left to discuss about ray optics, and then we should be done with ray optics in maximum 1 or 2 lectures. That's it. Is it? So anybody trying this question? Okay, guys, at least let me know if you're trying this. Again, use of proper sign conventions would definitely matter here. Okay. Okay. And right after this question, we'll move to our discussion on prisms. Okay, so hurry up. Okay, nobody answering. Nobody trying also. Okay, from the given information, what do you infer? You want a beam incident on the first lens, parallel beam incident on the first lens, leaving the second lens as a parallel beam. So from the given data, what can I say about the equivalent focal length? F equivalent should be infinity. A parallel beam incident on the lenses eventually becomes parallel only. So it focuses on infinity. So therefore, all I needed to do was I know since 1 over F equivalent is equal to 1 over F1 plus 1 over F2 minus D over F1 F2. Okay, so this should be 0. So all I need to do is just substitute all the values. 0 should be equal to 1 over F1. F1 is a concave lens. So concave lens will take the focal length as positive. Plus 20 plus 1 over convex, then concave lens. Concave lens of focal length 5. So I will treat this as minus 5. And should be equal to minus D over 20 into minus 5. Correct, guys? And this should be equal to 0. So let's see what that gives us. That gives us D over 100 should be equal to 1 over 5 minus 1 over 20. Okay. So that'll simply be 4 minus 3, 20. Okay. D over 20. So obviously D becomes 15. Okay, that is it. That is how you had to solve it. Okay, I hope you followed this. Okay. So now you could have logically also decided this. So see, this is your lens, this is your other lens. You would have logically also decided this without having to know the formula. You know that if a light beam is incident from here, so this will converge to F1. So for the second lens, you realize if this is F1 and if this becomes equal to F2, so any light ray that is emerging or diverging from F2 would have become parallel to the principal axis after refraction. Right? That is by definition of concave lens. So from here also you could have simply judged this. Okay. Oh, sorry. This would have gotten diverged further. Should have appeared to converge on F2. Should have appeared to converge on F2. Let's make that ray diagram again. That is what I made for concave lens, convex lens. Okay. This is how I would have liked it. If the ray appears to converge towards F2, then after refraction, it would have become parallel to the principal axis. So that is why you could have decided the distance would have been the difference of the mods of two Fs. Okay. 15 centimeter is the right answer. All right, now let's get started with our discussion on prisms. Okay. So what is a prism? Prism is a homogeneous, solid, transparent, refracting medium bounded by two plane surfaces inclined at an angle between them. Okay. So the difference between a glass slab and a prism is that the glass slab, two refracting surfaces are parallel to each other. Okay. So if you realize this and this surfaces are parallel to each other. And in lenses, the refracting surfaces are curved. So prism has two plane refracting surfaces. Okay. So two plane refracting surfaces and which are inclined at an angle. So you have this kind of prism. This is the most popular kind of prism that you have. You can have other shapes of prisms. Okay, so this is the traditional geometrical shape of an optical prism is triangular prism. Okay, it's not necessary. You could have even had something like this. As long as the refraction is happening through these two phases. This is also a prism. You do have prisms like this. Okay. Or you could have hexagonal prisms, pentagonal prisms. So depending on the cross-sectional, you could have had various kinds of prisms. The only condition for some refracting medium to be called a prism is that the two refracting surfaces should be not parallel to each other. Okay, so that's the only condition. So you can have many kind of prisms, triangular prisms, tetrahedral prisms, pentagonal prisms, even hexagonal prisms. But more often than not, we mostly talk about triangular prisms. So traditionally, our prism is supposed to be triangular of cross section. Okay, so it has a triangular base and a rectangular side. So you can see these three sides are rectangular. Okay, rectangular. You should be able to see that in the figure. And this is the base of the prism, which is, or the cross section of the prism, which is a triangle. Okay. Now, prisms can be made of any materials which are transparent to the wavelengths for which you're trying to produce these dispersions or deviations. So, Rinkia, hey Papa, so is it possible to do questions on principle of superposition using vector components like f1 cos x and f2 sin x? Yes, it is. So, are you talking about superposition? In what sense? A superposition of currents, if you talk about, they are definitely done by that. If you're talking about the phasor method, right? In the phasor method, yes, you can do. You can do that. Okay. Of course you can. Okay. I think you're referring to the phasor method. Phasor method is nothing but vector sum. No, so vector sum definitely can be achieved in terms of components. Okay. So in electrostatics, is it possible to do questions of principle of superposition using vector components like f1 cos x and f2 sin x? Again, in superposition, if you're vectorially adding the two components, then also, of course, why can't you add it with components? Of course you can. Of course you can. So I'm not sure if I'm following your question very well, but Superposition involves vector addition. So vector addition can definitely be done in by breaking it into components. Okay. Hello, Mahi. How are you? All right. So let's talk about some important terms related to prisms. Okay. So first we'll talk about the angle of prism. The angle of prism is the angle between the two refracting surfaces of a prism. Okay. So imagine if this is a prism. So what are the two refracting surfaces? You will realize first refracting surface is this. The second refracting surface is this. So the angle between the two refracting surfaces, this is the angle usually traditionally the symbol used is A, and this is called the angle of prism. Okay. Now you have two other angles also, but you don't call these angles angle of prism unless the refractions were happening from this and this surface. Then this would have become the angle of prism. If the refractions were happening from this and this surface, then this would have become the angle of prism. So it's the angle between these two surfaces that are from where the refraction is happening. Okay. Next, of course, you have angle of incidence. So the angle made by the incident ray to the normal on the first refracting surface. So if the ray is incident on this, so if you draw a normal on this surface, so this is a normal on this surface. So the angle made by the incident ray with the normal is called the angle of incidence. Then you have angle of emergence. Angle of emergence is this angle. Okay, it is the angle made by the emergent ray. This is called the incident ray. And this will be called the emergent ray. The ray that is coming out of the prism, emerging out of the prism. Okay. Okay. So with basic terms known, now let's try and identify relations between these different angles. So what I can say is if I look at this triangle, so first of all, if the prism has a refractive index of mu, so and R1 is the first angle of refraction, then what I realize is for this refraction, this angle would be R2. Okay, R2 would be the angle of incidence for the surface number 2. Okay. And E is the angle of emergence. Okay. Now what I can see is that the first relation between I and R1 is by Snell's law. By Snell's law. What I can say is sine I equals mu sine R1. So that will be the relation between I and R1. Similarly, okay, so what? So what I'm saying is that in electrostatics, the question had three charges, and we have to find the force on one, which should be the root of F1 plus F2 plus. Yes, of course, you can do it with component methods also. Of course, this is vector summation, no? So yes, you could have broken the force into x and y components, found the net x component, net y component, and then fx square plus fy square का root would have been the answer. ठीक है? तो जब वेक्टर समेशन कर रहे हो तो चाहे तो दो वेक्टर्स a और b आप ये इक्वेशन से ऐड करो, which is the triangle method equation, या फिर कंपोनेंट से ऐड करो, एक ही बात आएगी. You would have gotten the same answer. ठीक है? कोई दिक्कत वाली बात नहीं है. उससे भी आंसर आएगा. ठीक है? वेक्टर सम ही है, उसमें कोई कोई बड़ी बात नहीं, कोई नई बात नहीं है, कुछ अलग नहीं है. ठीक है? Also I can say sine mu sine R2 would have been equal to sine E. So this will be the relation between R2 and the all right, no problem, no problem, and the angle of emergence. Okay. Now what you will realize is that okay. So this essentially would have been R1 plus R2. Why it has written R1 R2 here? 2 is wrong. This is the exterior angle of this triangle. Would have been R1 plus R2. Anyhow, let's forget that. Now, if I look here, what will be this angle? This angle This would have been delta 1, right? And finally, if you have this angle, this would have been delta 2. Okay. And the net deviation would have been equal to, this is the net deviation, this is the original path of the incident light, this is the final path of the emergent light. So the angle between them is delta, which is the net deviation produced by the prism. Okay, now this delta would be equal to delta 1 plus delta 2, correct? Okay. Now I will also write, let's find some more angles. How about this entire angle? This entire angle. This entire angle, can I say, would be 90 minus R1. Why? This entire angle is 90. Okay, because this is the normal. Now, similarly, if you talk about this entire angle would have been 90 minus R2. Okay. Now let's also give names to these points. So let's call this B and let's call this C. Now, if you take a look at triangle ABC, in triangle ABC, what you realize is A plus 90 minus R1 plus 90 minus R2. This is the sum of the three interior angles, and this should be equal to 180, correct? So which gives you R1 plus R2 equals A. Very important. This is the third equation that we have gotten. Okay, so first two equations are simple Snell's law, where I relate the incident angle to R1, the R2 to the angle of emergence, and finally we have a relation between R1, R2, and A. Okay, now you can also relate the deltas, okay, and find the final deviation. Uh, let's add one page here. So from the refraction from the first surface, what you realize is delta 1 would have been I minus R1. You know, that is the deviation produced by any refraction. After any refraction, the angle of deviation is I minus R. Similarly, what will be delta 2? Delta 2 would have been E minus R2. Right? That is the deviation produced by the second refraction. So the net deviation, which is a delta, would have been nothing but delta 1 plus delta 2. So can I say delta is equal to I minus R1 plus E minus R2? What I realize is delta becomes equal to I plus E minus R1 plus R2. And we already figured out what R1 plus R2 is. R1 plus R2 is nothing but the angle of prism A. So delta of a prism is this. Very important. Okay. That is the angle of deviation produced by a prism. It is I plus E minus A. Again, important equation. Okay. So again, I hope everybody followed this also. Next, we'll talk about condition of no emergence. So there will be a certain condition in which a light ray enters this, but from instead of coming out of here, it actually gets reflected back. So in this case, it does not. This is called the condition for no emergence. No emergence means that any light ray entering the refracting surface 1, so let's call this refracting surface 1, does not emerge out of refracting surface 2. In fact, it may or may not come out of the third base. Okay, or maybe it gets reflected from the base also. So what do you want for such a thing? For such a thing to happen, you know that R2 should be greater than IC. Great. For such a condition, your R2 should be greater than the IC, IC being the critical angle. Agreed? If IC is the critical angle, then what you realize is that if R2 becomes greater than IC, then this will happen. There will be no emergence, right? Also, so what you realize is that A equals R1 plus 2. Okay. So from here, I can say R2 was A minus R1. And can I say therefore A minus R1 should be greater than IC? Okay. Now I can also say therefore A should be greater than IC plus R1. Okay. Now what is the maximum value of R1? What is the maximum value of R1? The maximum value of R1 in fact is IC. Okay, for normal incidence. Okay. Since sine I equals sine R1, mu sine R1. So the greater the I, the greater would be R1. So what is the greatest value of I? The greatest value of I is nothing but 90. So the greatest value of R is the R corresponding to 90-degree incidence, which is in fact the critical angle. Okay. So I know. R1 max equals IC. Therefore, if A is greater than 2 times IC, if A is greater than 2 times IC, then you realize R2 will be greater than IC. So the angle of no emergence is that A should be greater than 2 times the critical angle. Okay. A greater than 2 times critical angle equals condition for no emergence. Great. So this is important. Condition for no emergence is this. No worries. This is my condition for no emergence. So if your angle of prism A is greater than 2 times the critical angle, then no ray entering surface number 1 can emerge out of surface number 2. Okay. Next, what we can have is condition for grazing emergence. So if it just barely reaches out, if it just reaches out, in that case, you realize R2 should be equal to IC. If the second R2 angle is equal to the angle of critical angle, then you have your light ray coming out at 90 degree. Okay. So since this is that, so what you realize is correspondingly, you will realize you will have some value of I1 and R1. Okay. So this just one ray can emerge, and that too for grazing incidence. When will that happen? When will that happen? If A equals to C, then you could have had just one ray emerging out for grazing incidence. Okay. Now again, you will also realize also for any ray, any ray incident on surface 1 come out of surface 2. So if that is the condition that you're looking for, you want any ray that enters surface 1 should come out of surface 2. Then what should be the condition? Can you figure out the condition? Your angle should be less than the critical angle. Angle of prism should be less than the critical angle. Okay. So I know R2 should be less than IC, less than equal to IC for all R1, and R1 is less than equal to IC for all I. Okay. Now you also know since A equals R1 plus R2. Okay. So R1 you realize lies between 0 and IC in fact. So if you want this to happen, then what you have is A should be less than equal to C. For this condition, all the rays incident on surface 1 will eventually come out from surface 2. Why? Because if your angle of prism is less than the critical angle, okay, if your angle of prism is less than equal to critical angle, then you realize since A is equal to R1 plus R2, so what is the minimum value of R1 that you can have? The minimum value of R1 could have been 0. So you realize the maximum value of R2 would have been equal to A. And if that value is less than critical angle, then all your rays entering the phase 1 would come out from phase 2. Okay? So if you want no rays coming out, no rays incident at phase 1 coming out of phase 2, then this is the condition that angle of prism should be greater than 2 times critical angle. If you want all rays incident at phase 1 coming out of phase 2, then the required condition would be angle of prism should be less than the critical angle. And if your angle of prism lies between I and 2I, IC and 2IC, then some rays would come out, some rays will get reflected back. Okay. For A between IC and 2IC, some rays incident on surface 1 would emerge from surface 2. Some will not. This is the middle condition. Okay, this is the middle condition. For angle of prism greater than 2IC, you realize all rays entering from phase 1 would get totally reflected back by surface 2. For A less than IC, all rays entering surface 1 would come out of surface 2 if the angle A lies between this range. Then some rays would come out, some rays would get reflected. Okay. Now, deviation of prism, I think we already calculated. Okay. We already calculated that deviation produced by the prism is given as delta is I plus E minus A. Okay. Now you will realize that from principle of reversibility, let's make a note. It's a very, very important note. So from principle of reversibility of light, what you can realize is that if the light ray was traveling like this, it goes like this. If the light ray is incident in the opposite manner, if I incident the light like this, then it would have retraced its path. So if the angle of I was made equal to E, then E would have become equal to I. So from the principle of reversibility of light, I can say if I is changed to E, E changes to I. So E dash changes to I. So what you realize is that delta deviation, same amount of deviation is produced for two angles of incidence. Okay, so therefore, two angles of incidence result in same deviation. And these angles are I and E, where E is the angle of emergence for I. So if you incident the light ray at an angle of incidence I and it emerges at E, once you would have made the angle of incidence as E also, you would have seen the same amount of deviation, because then the angle of emergence would have become I, and this equation is telling you that delta is I plus E minus A. So I plus E of course remains same. I becomes E, E becomes I. Okay, so that is the logic. Now, therefore, if you talk about the deviation produced by a prism, then this is what the graph looks like. Okay. For the delta to be maximum, you want either I to be maximum or E to be maximum, and I or E maximum can be 90 degrees. Okay, so you realize that the maximum deviation is produced by two angles. One is I min, for which the corresponding angle of emergence is 90, and one for I equals 90, for which E becomes this. Okay, so that is where the maximum delta is produced, and the graph would be something like this, so that you realize for one delta you have two angles. So if this is some I, then this is the corresponding E. This is the corresponding E. Okay, this is the graph of delta or the deviation produced by a prism. You will have one deviation produced by two angles, one I and the corresponding E. Okay. Now what I can say is, for max deviation or maximum deviation, I realize is either I equals 90 or E equals 90. Okay. So that is when the maximum deviation is produced. Also, for minimum deviation, I equals E would be the condition. Okay, you realize this is very similar for ranges of a projectile corresponding to two angles, theta and 90 minus theta. You realize the maximum range is achieved when the two angles are equal. So here also minimum deviation is achieved when I equals E. So therefore, delta min equal to 2 times I min, I for minimum angular deviation minus A. Okay. Now that brings us to another very interesting situation. So these are the deviations produced by a prism. Okay, so delta min would be equal to I corresponding to the minimum angle of deviation minus A. Now because of that, what I can say is, therefore I minimum deviation can be written as delta min plus A over 2. Okay, this is another very important relation. Okay, Now, because of this, what you realize is that you have a method of finding out refractive index with minimum deviation. So, in a labs, to find the mu of the material of the prism, delta min is found experimentally. Okay, you experimentally find the delta min. Now, once you find that, what you will realize is that, okay, so I think that's why also you realize, since for minimum deviation, I was equal to E, therefore, and I can say sine I was equal to mu sine R1 and sine E was equal to mu sine R2. So therefore, what I realize is R1 is equal to R2. Okay, so for minimum deviation, I equals E, and of course R1 is also equal to R2. Okay, now that is the fact that we are going to use here. So when the delta is minimum, since when delta equals minimum, I know I equals E, and I for min deviation becomes equal to delta min plus A by 2, which we have already figured out, and also R1 equals R2. So I know R1 plus R2 equals A. Therefore, R1 would be equal to A by 2. Read. I hope you guys can figure that out. We have already established this equation, right? I have already shown you this. R1 is equal to R2. And since R1 becomes equal to R2, so I can write R1 would be A by 2, which would be equal to R2 also, of course. So now what you realize is from Snell's law, okay, from Snell's law, mu would be equal to sine I over R1, sine of R1, correct? So I can write this as sine of delta min plus A by 2 over sine of A by 2. This is a very, very important expression right here. Very important expression. This is how you can find the refractive index of the material of the prism in a lab. Okay, this is the method we use. All I will do is I will subtend different light rays. I will incident different light rays at different angles on a prism, and finally find out just the minimum angle of deviation. So in a lab, what you do is you keep a prism, you keep changing the angle of incidence on the prism, and you keep measuring the deviation produced. If you can figure out the minimum deviation, the angle of minimum deviation, then you can figure out the refractive index of the material by using this formula, that mu is equal to sine of delta min plus A by 2 over sine of A by 2, where A is the angle of prism, and that is known. Okay. Again, remember this. This is very important. This formula is very important. A lot of questions have been asked in a JEE from this formula. Okay, so let me maybe write it again. Mu equals sine of delta min plus by 2 over sine of A by 2. Very, very important formula. A lot of questions are asked from this formula. So must remember. Okay. All right. So let's move on and practice some questions then. Okay, so that's the theory that I wanted to discuss for today. Let's just discuss maybe a couple of questions, and then we can end today's session then. Okay, so this is the first question I have for you. So you have an equilateral prism. You have an equilateral prism, and you've been told that a ray of light is incident on one face of a prism, which is mu is equal to 1.5. If the angle of if at an angle of 60 degree, if the refracting angle of the prism is also 60, so angle of prism is also 60, angle of incidence is also 60. Find the angle of emergence and the angle of deviation. Is there any other angle of incidence for which the same amount of deviation is produced? So try this. This should be easy. Let's see. You've been told the I, you've been told the mu, and you have been told the angle of prism A. Now you're expected to find the angle of emergence and the angle of deviation. If you can find the angle of emergence, the angle of deviation is already known then. Okay. Essentially, you need to find the angle of emergence. So how you would have gone about this? Okay, so why don't I show you? So I would have simply said from Snell's law. From Snell's law, we would have said sine of 60 would be equal to mu sine R1. Okay. Put 3 by 2 would have been equal to 3 by 2 sine of R1. So I get sine R1 is 1 by root 3. Okay. So R1 would have been equal to sine inverse of by root 3. Here you would have had to use the calculator, or you should have been given the value of sine inverse of 1 by root 3. So in JEE, they will give you the value of sine inverse of 1 by root 3. So let me just use the calculator. The answer quick. Strangely enough, my calculator does not have sine inverse function. Okay, no worries, no worries. The phone calculator doesn't, but I'll Google it. Sine inverse root. So 35 degrees roughly. So turns out this is 35 degrees. Therefore, R2 would have become 60 minus 35 would have been 25 degrees. And once I know R2, 3 by 2 sine of 35 would have been equal to sine of E. Okay. So from here, you would have figured out the angle of emergence also. Okay. All right. And let's see. Calculate this. .63 it is coming. Okay, so So yeah, it's almost coming out to be equal then. It's almost coming out to be equal. Almost. Slightly less. He is almost 35. This is 25. So it is almost, I think, less than this. 56 degrees. Okay, so the angle of emergence is 56 degrees. Now you know the angle of deviation also. So once you know this, you also know delta. Okay, so delta, as you know, is I plus minus A. So this would have been equal to angle of emergence, which is 56 degrees. Okay, right. Or 50 degrees would also. Okay. Now, is there any other angle of incidence for which the same deviation is produced? Yes, there is. If I equals 50 degrees, then you will get the same deviation. Okay. All right. So I had some more practice problems for you. But I think we have run out of time for today. So we will start the next session with these practice problems. So go through today's session. Make sure you followed every part of the discussion. Okay. And if there is any confusion about any of the things that I discussed, then you can leave your thoughts in the comment section, or you can even ask me in the next live session. Okay. So that is where we will wrap up today's discussion. The rest of the discussion we will have in the next session because we are out of time for today. Okay, but before I wrap up today's session and before I take your leave, let me just quickly remind you that if you haven't gotten your Unacademy subscriptions yet, and if you're planning to get them, then these are the steps that you need to follow. You can go to the plus section of the app, select your goal as IIT JEE, and click on the get subscription button. Okay. Next, of course, when you do that, you will be redirected to the payment page where you will find yourself a box which will say, do you have a code? That is where you can enter this code, RD Live. This code will give you a 10% off on all your subscription fees, be it your plus subscription or be it your iconic subscription. Now, the fees of all these subscriptions are as mentioned below. Okay, now you will also realize when you click on proceed to pay, you can choose from a lot of no cost EMI options to break this payment so that you don't feel the burden of these payments also. Okay. Next, of course, those of you who don't know what the iconic subscription is, so iconic subscription is a different new offering made by the Unacademy. Okay, so this subscription will make sure that your IIT preparation goes to the next level by allotting you personal coaches. So from our team of experts, you get personal coaches allotted and you get these extra benefits apart from your plus benefits. So they help you power through your IIT journey. Next, again, for students who have just entered their class 11th and are looking for a single one-stop solution for all their preparation needs, can go for the combo subscriptions offered by the Unacademy. So there are 4 combo subscriptions which are being currently offered. Okay, and these combo subscriptions are as follows. The first combo offers you the iconic subscription for IIT plus subscription for 11th and 12th. This combo starts at around 4,600 a month. The second combo offers you the iconic subscription for your IIT plus CBSE 11th and 12th. This combo starts at 5,500 a month. The next combo offers you the plus subscription for IIT JEE and your 11th and 12th. This combo starts at 3,000 a month. And finally, you have a combo which offers you the plus subscription for IIT JEE and the iconic subscription for class 11th and 12th. And this combo starts at 3,900 a month. Next, here is a list of the upcoming tests in January. Make sure you're not missing out on any of these. The next Unacademy Combat is going to happen live on the 31st of Jan, in which you can enroll right now using the code RD Live. And then you have AIM Advance tests for 2021 target happening every Saturday. Do not miss out. This is very important for all 2021 aspirants. And then finally, of course, you have unique DPP discussions happening from every Monday to Thursday. Okay. Now, if you like today's session, then do not forget to press the like button and share it with as many people as you can, because we at Unacademy realize that not all students can afford these subscriptions. So we are making this content free, completely free, available to all. So whoever student is looking for any kind of guidance, this content is being provided free for them on through this YouTube channel. So make sure you're using you are sharing this with more and more students so that more and more students can benefit from this amazing free quality content. Now, if you're new to this channel, don't forget to subscribe and don't forget to press the bell icon. PDF of all the slides used in today's lecture will be available for download very, very soon. Now, those of you who are following us on the JEE English channel of YouTube should not forget to connect with us on the Telegram app using this link. Okay. And that will make sure that you're getting all the timely notifications of every lecture and session happening on this channel of YouTube. So that is where I will wrap up today's session. The rest of the discussion about prisms we will have on the next Tuesday. Okay, till then, you guys keep studying hard and keep taking good care of yourselves. And just before I wrap up, let me remind you, this is the code that you want to remember. RD Life. So this code will help you unlock free features. Okay, unlock free features of the app. Get 10% off on Plus and iconic subscriptions. And helps you register in different events also. So register in Unacademy Combat and other events. So you can use this one code in multiple ways. So you can install the Unacademy app, unlock its all its free features using this code. You can get a 10% off on all your fees of whether be it the Plus subscription or the iconic subscription, or you can register for events like Unacademy Combat or the Unacademy Champs event that we just had using this code. Okay. So that is where all the information that I wanted to give you today, apart from the teaching. All right. So with that, I'll take your leave now. You guys take care of yourselves, and I'll see you next Tuesday. Bye bye.